Okay guys, so we're going to go ahead and start in this section. It should be 5-3, and it's called adding and subtracting radical expressions. In the previous section we multiplied and divided radical expressions, and we had a set of rules that we used. Now we're going to subtract and add radical expressions, and we also have a pretty much one rule to follow. It's over here, so let's be sure to be taking notes, Cornell notes to be specific. So here's the rule. 1 can only add or subtract radical expressions if the index and radicands are the same. So these has to match the index and radicands. And here's a friendly reminder of what the index and the radicands are. So if I have my radical, and I have a. So this guy over here is called the index. And this guy over here, inside the radical, whoever's inside the little house, it's called a radicand. So the rule pretty much tells us that we can only add or subtract two different radicals if the index and the radicands match. So here's an example of this. So let's take a look at an example. Let's call it example 1. Let's say that I have 3 square root of 2 plus 2 square root of 2. So first of all, I'm going to take a look at my rule. I want the index and the radicals to match. Otherwise, I cannot add them. So in this case, the index is 2 and the index is 2. So the index matches. And the radicand is 2 and is 2 as well. So the radicands match. That means that I can go ahead and add them. At this point, all you're going to do is take a look at, oh, sorry, I have an email, guys, at the numbers in front. And you're going to do what's a 3 plus a 2? Correct answer is 5. And you're going to leave the other two as they are. So that's a simple, the most basic example I can give you. Use it to Here's another one. Let's say that I have three times 5x, the square root of 5x, sorry, minus 2 square root of 5x. So we're going to go ahead and take a look at the same things. We want to check that the index is the same and that the radicand is the same. So what's my index here? It's 2. My index here is also 2, so these match. What about the radicand? The radicand is 5x and 5x. So the radicands also match. Therefore, I can easily combine these two. I'm going to take a look at the 3 and the 2. What's 3 minus 2? The correct answer is 1. And you keep everything else the way it is. And notice that this is not necessary, but I'm just putting it there to show you. And your final answer would be this. And if you're asking if this is necessary, it's not. In fact, I'm going to give you a more simple answer. Because remember that the 2 can be removed from the index, and so can be the 1. Okay? Okay guys, so I'm going to go ahead and give you an example. Let's see what happens if I give you something like 6x squared square root of 7 plus x squared square root of 5. Now, we're going to follow the process, and we have an index of 2 on both of them, so the index matches perfectly. But now we're going to take a look at the radicands. And you probably already figured out that 7 and 5 are not equal, so the radicands do not match. So our answer should say something like this: the radicands are not the same. We cannot combine the expressions. Okay? Okay guys, so here's another problem. We're asked to find the perimeter of a window of length 15 square root of 2 and width 10 square root of 2. So first let's go ahead and collect information that we need for this. Keywords here would be perimeter. And perimeter is actually a math word that represents the distance around an object, and you know this from previous years. But so getting down to the beef of things, the formula for perimeter would be P equals 2L, and I should probably use different colors for this. I'm actually going to use 2L plus 2W. And again, this is a formula that's usually given to you, and that all that requires from you is that you know how to substitute, which you normally do very well. So let's go ahead and do so. If we substitute, we're going to have that the perimeter is 2 times L, but L is 15 square root of 2, so I'm going to put that in parentheses. Remember, the parentheses represent multiplication. Next, I'm going to do plus. The 2 again comes from the formula, and my width in this case is the 10 square root of 2. So let's go ahead and do some math here. We have 2 times 15, which is 30. We just carry the square root of 2. And now we have 2 times 10 is 20, square root of 2. And now we proceed to check for the index and the radicands like we've been doing, because it's just an addition. So let's go ahead and take a look at this. The index is 2, and the radicand is also 2. So pretty much if everything is the same, you're just going to add the coefficients in front. And my answer becomes 20 plus 30 is 50 square root of 2. And again, remember that that's optional. One final thought that I want to kind of give you to remind you of this is, let's say that I have 2x squared plus 2x to the third. This goes back to polynomials and what we did a few units ago. Know that we cannot add these two monomials because the algebraic part is not the same. So we cannot combine them unless they are exactly identical. And that holds for radicals. So if that helps you remember it, please keep that in mind.